Okay, so today's lesson is 11.4, arcs and chords. You guys had your objective written at the top, which is use properties of chords and circles. Your warm-up is to draw the central angle. We see that the central angle is right here. It's AOB. It starts at the center, so it's any angle that starts at that center. And then we had the minor arc, which was AB. And we had our major arc, which is ACB, and we had to put that arc above it to tell us that was our major arc. We also have to identify our radius. So can somebody tell me one of our radii? Yep, Lanaya? So not, no. Yes, CO could be a radius. Yeah, it's not drawn in, but we can definitely do it. So let's go here. I'll draw it in. Can you see that? CO. We could have also had what? OB. And? AO. So these are all the radii. Okay. So this is our warm-up. Our theorem here. If the diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So what does it mean to be perpendicular?
Like this.
Yes, like that, which means?
Lines that intersect at a point.
Intersect and form a?
90 angle.
90-degree right angle. When it says bisect, what does it mean about these two segments? Yep, they're going to be the same, and that also means that the arc and the chord, so that means that these are also going to be the same. Okay, so our next theorem is if one chord is the perpendicular bisector of another chord, then the first chord is the diameter. So if we see that it's been bisected, forms that right angle, then we know that this has to be the diameter. Okay, so you see that you have a diameter, goes to the center of the circle, or at least what should be the center of the circle. It is it is cutting this in half. What do we know? I gave you the answer. Okay, so we see we have a diameter and a chord formed by a right angle. What do we know about these two sides? They're going to be congruent based on that last theorem. So what does that mean? The x has to be? 6. X has to be 6. Let's try this again where I don't tell you the answer. Okay, you have a diameter. Goes through, forms a right angle. What do we know about these two? You see here that what happens here? These have to be congruent. Yep, set equal to. So what we're going to do is we now have x plus 4 equals 3x minus 6. Combine like terms, so I'm going to subtract my x. I end up with 4 equals 2x minus 6. Got to add my 6 to the other side as my constant term. I have 10 equals 2x. What do? Divide 2 from each side. X equals 5. So this theorem says in the same circle or in congruent circles, if two chords are congruent, then their corresponding minor arcs are congruent, so the one's less than 180 degrees. And then our other one with this is if two minor arcs are congruent, then their corresponding chords are going to be congruent. Okay, so our first one we see we had congruent arcs, which meant the congruent chords that correspond to them have to be, or the chords that correspond to them have to be congruent, which means they have both to be 12. Over here, you see that you have this angle, the central angle, which is 115. It means the arc that corresponds to it, so that minor arc FG has to be 115. You could also do vertical angles that are congruent if you could guarantee that these were both straight lines. And we see here if this is congruent and this one's congruent, that means that this angle also has to be 115. Okay, so on this first one, you see you have congruent segments of a congruent chord, and it's been bisected. So this arc here is 75. That means this one has to be? 75. Has to be 75. And then over here, you see that these are congruent and these are congruent, which means that both of these have to be? 120. 120.